So Chris, I hear you have some of the best practices for securing identities in the cloud.
Yes, thanks, Ken. So today I kind of wanted to talk about just going over how to use managed identities and how to protect them in the cloud. It could get a little out of hand because there's different types. A lot of resources in the cloud are ephemeral, deployed with automation. So it could get pretty hard to track as time goes on. So I just want to first go over best practices with using different types of identities in the cloud, go over some benefits of using them, and I'm going to talk a little bit how I use them to build secure DevOps CI/CD pipelines and applications. So the first thing I would suggest to know when using cloud identities is understanding what your application requirements are and what the different type of identities can do for you. So for example, in Azure, there's system identities that can be tied to the lifetime of your resource. So think of like a VM. I can give the VM a system identity during deployment. I can give it access to a storage account to read data or write data to for whatever my application requirements are. There's user identities, which you can create that ahead of time and apply it to multiple different resources. So if I have 20 VMs, they all need the same access. I give them that one user identity instead of having 20 different identities.
Do you think maybe for some of there might be some new viewers or folks who might not be as familiar with cloud identities? Do you think maybe we can give them just a quick high-level view of what exactly an identity is and what you are able to do with it?
Think of it just as a user. It's like your credentials you use to log in, for example, to your laptop or to whatever single sign-on system you use. But now it's no longer tied to your user identity and tied to a resource.
It's essentially for whatever application or cluster or group you're trying to access, correct?
Yes. So I know some organizations, let's talk about like on-premise and just not worry about the cloud. Some organizations create a user inside their Active Directory, their federated Active Directory. And this is basically the same thing, just it's abstracted to be used in the cloud. So each cloud provider does it a little differently. Microsoft with Azure is very heavily tied to Active Directory, whereas AWS has their own users and groups, and you can tie it to different federated systems. So I hope that explains it a little better at a little higher level.
Mm-hmm. Yeah, I think so. Sorry to drag you backwards, but let's go back to, I think you were talking about how Azure tries to, whether it's deploy or enforce identity management here.
Yeah, so what Azure does is they tie everything, since Microsoft originally created Active Directory, they call it Azure Active Directory. So for their cloud. So every time you create an identity, like let's say I spin up a new virtual machine and give it a managed identity, it ties it to the lifetime of that resource and it creates that identity in Active Directory. So the benefit of that is that it's federated. It makes it easier to track. And Azure does that automatically. You can also do that in AWS. Tie groups. AWS calls them groups, but AWS groups tied to your local Active Directory. And that's one of the main best practices I wanted to talk about is having them federated if you can, because in there it makes it easier to track. Whereas if you're an organization with, let's say, 100 different AWS accounts, it could be hard if there's not some federated system to keep track of all the different AWS groups that developers can make.
Yeah, it almost sounds like they being really any of the providers try to make this as easy as possible to spin up a new identity or user, so to speak, depending on which provider this is. So I wonder then, does that then lend itself to, because they make it so easy, are there then some best practices that you can then follow to make sure everyone's doing things as consistently as possible, and you don't have Group A doing things one way and Group B doing them a totally different way?
Yes. So it does make it, the cloud is what I would think is first flexible, and then you have to put kind of layers on top of it to kind of put some control in there.
Yeah, so that's really good then. So there should be some kind of periodic check into who has access. So like you said, following lease privilege and ensuring not only lease privilege, but is this identity or user still required?
So another good practice when creating cloud identities is to put in place a system that has an approval process. So for example, a company can have a company's employee could at request to create a user, and the organization's program or whatever vendor or system they use, they're able to check the access, have any requirements on it, and have the user attest to that identity every so often, whatever the policy you might have in your company, or requiring changes to identities or key credential rotations. So to add a little more about least privilege as an important policy to use when creating applications and identities. And what I kind of want to stress is that least privilege is everyone's responsibility. It's not just the policy organization, and it's not just the developer. It's everyone who is dealing with the application. Because in the cloud, it can get tricky. So I feel like an identity that only has access to an Azure function, and they think, and the developer might think, oh, I'm good. I'm only giving it access to the function. However, the function has access to read a storage account. So there could be some data leakage there. So those are little things that as a developer and a user, you got to keep in mind. And
you have to understand a lot more about what you're potentially exposing holistically, right?
yes. Yep. So and since cloud, a lot of things are ephemeral and spun up quickly, it can be hard to track. So it puts a lot of work on the developer, and or I should say puts a lot of responsibility on the developer. Because even if you have, like, say, the best corporate policy or just alerting on systems, like the policy team or security team at your organization may not understand the requirements of your app. So it's going to be hard for them to tell if your application is following least privilege, because they don't know exactly that they need access to multiple containers in the storage account. But as the developer, you know that I only need access to one container in a storage account. Or if we want to talk about S3, AWS, directories in an S3 bucket. So it's, I can't stress that enough as a developer. Even if you have no security background at all, you just have to follow. You have to do your best to follow least privilege and understand what your application does.
So if we take the example of giving someone access to the function, and they think, oh, okay, I only have access to, I don't know, we'll just call it README or something, and README actually has access to read the entire storage account. What's the best way to go about actually getting that person access without potentially giving them read to all of the storage account?
We know that the function can read the storage account, so there's some requirement or reason that the function can read the storage account. So if you don't want that user or what other resource access to that data, you can spin up a new function.
So making sure that the function is really as restrictive as it needs to be for who's accessing it, right?
Right. And the benefit of the cloud is that the cloud doesn't have to be a monolithic application. You can divvy some stuff into call them microservices. You can have 100 different applications running on different functions to help break up what your application does. And even with that, if I can go a little further into that with encryption keys, when I build applications in the cloud, I give everything their own encryption key. So, for example, if I'm spinning up a VM that's doing data transport, I'm using a different encryption key for that's saving my data in a storage account at rest. So therefore, that's good for like blast radius too. So if there's a major disaster and you lose an encryption key, you don't lose your whole environment. You're just partially, you need to recover part of your environment.
Right,
And
right. You don't have to replace 100 keys. You only have to replace a single key.
right. And to tie it back to identities, having different encryption keys is also following least privilege. So if you have an identity on the VM, it only needs access to a single encryption key. You don't want to give it access to every single encryption key in your environment.
Right, right. So it both makes sure that you're following the good practices there of least privilege, but you're also, as you kind of alluded to before, ensuring that if there is some kind of leakage or issue you run into, you're minimizing the impact that you potentially get exposed to. And do they make that pretty easy across the different cloud providers that you've experienced, like to manage and set up?
Yes, I would say that it is definitely different in each cloud. GCP, Google does it totally different from how AWS does it, and Azure does it totally different from how AWS and GCP both do it. But they both do the same thing. Where in Azure, you can have Azure roles only access a single KMS key in your key vault, and AWS can say in AWS each KMS key has a policy, and you write your own policy on each of those. So they both, yeah. So it's just different ways of doing the same thing. Both are secure and both allow for least privilege principles. Yeah. So least privilege principles are extremely important when building resources and identities in the cloud, regardless of your cloud provider. And when I think of least privilege, I think it's everyone's responsibility, the policy team, the security team, the app team. And as a developer who works with a lot of resources in the cloud every day, it's important to know your application and to know each little nuance and to understand that, hey, this resource or function or storage account or a virtual machine only needs access to this particular key or resource or another storage account. So now I want to talk about how you can utilize cloud identities into building secure CI/CD pipelines in applications. So a couple pipelines I work with every day is Azure DevOps and AWS code pipelines. And what I really like to use identities for is to use in Azure. I like to use system identities, and the reason for that is because they're passwordless. They have their own identity that's tied in Active Directory and are able, on behalf of like a user or application, to grab a JSON web token and authenticate to Azure Active Directory for me. Therefore, as a developer, I don't have to worry about rotating secrets or other credentials or having them leak into Git repos or files in a virtual machine. So I do think there's a huge benefit of using either a user identity in Azure, system identity in Azure, and in AWS. They call them IAM roles. And those are just forms of passwordless ways to authenticate to other resources in their cloud providers.
Does it therefore make it harder to set up one of those passwordless environments, so that what kind of restrictions go into who can do that, or how it gets set up? Is that just a process at the insert company name or wherever, or is that a pretty standard layout, depending on which cloud operator you're using?
Yeah, that's a good question. I would say it actually makes it easier than harder, because back in the old days when you're like on premise or on your servers, you have to have like a password to get into your Hive database, or even worse, they might not even been a password. But these cloud providers require you to authenticate. So, for example, if we take Hive, like I talked about on premise, and in Azure they have this application called Azure HD Insights or an Azure Data Lake, and you can run Hive on top of these cloud resources. And by spinning up my identity, I can spin up, let's say I have like my build server for building applications or updating resources and applications. Say I want to run a Hive query, I can have the authentication built when I spin up my build server and say, hey, I want this managed identity to be able to read from the Hive database. So what you do have to do is make sure you have proper firewall policies, right? You don't want your server exposed publicly. But with that, with managed identities and token authentication, you don't have to worry about passwords. So I've seen plenty of times just on public GitHub repos, none that we use here, but if there are these scrapers that people scrape for AWS and Azure credentials in public repos. So, and adversaries do that all the time. So by not even having to worry about the password, it makes it inherently more secure.
Nice. Yeah, and anytime you have to worry less about that getting out there, it's definitely a positive there.
Yeah, and it makes it much easier on the developer too, because if you have a company policy that says, hey, you need to rotate these keys every 90 days, it takes a larger effort, because you have to make sure your application isn't affected when you have to rotate these keys, and it's just another process you have to worry about. And with some of these cloud identities, it makes it much easier and much more secure.
Yeah, I do have to call you out though, because you said in the old days, and to some people the old days could have been 6 months ago. So it's definitely, things certainly changing very quickly. So it's good to be able to see that a lot of this has been thought out, as people are often trying to get into these pipelines as quickly as possible.
Yep, that's a good point. And something I see a lot is that when people first start going in the cloud, the number one issue I see is misconfigurations. So with new stuff in the cloud, you got to take the time to kind of read and understand it before just pushing out and playing with it. So when building secure CIDC pipelines, a good method of using is potentially using managed identities. Managed identities are passwordless, but passwordless doesn't necessarily mean you're not authenticating properly. Identities, some of these managed identities in your cloud providers allow for token authentication, so your resource is able to, on your behalf, authenticate to a storage account or S3 bucket or data factory, or for example a Hive database running in like an Azure HD Insights, or should I say just an HD Insights, take Azure out of it, because each of these cloud providers have their different names, but in short, passwordless takes a lot of effort off the developer. So the developer doesn't have to worry about rotating the password, and they don't have to worry about it leaking into Git repositories. And even if you have a private Git repository, do not put AWS or Azure secrets in your private Git repo either, because you never know. If your repo gets public, I believe it's only a few seconds to minutes that your credentials are stolen on the internet. But that's why using passwordless token authenticated managed identities is better. You don't have to worry about saving or rotating any of those credentials.
So when, it's a really interesting thing and it sounds super beneficial, but part of me also sits here and says, but we've been saying for how long there should be 2 factors of authentication, right? And now we're talking 0 factors of authentication. So how exactly on the, I guess it would be the server side or the cloud side, does this get managed so that it verifies your identity belongs to what it should?
Yep, that's a great question. And I know there are policies in AWS and Azure that you can add that requires MFA for everything. That does affect your application. Your application does need to be able to work with that. So depending on what your team does, I would look into that. But one high in the sky idea I would say is that with the growing push for zero trust and trusting like device, not just the user's credentials, I think managed identities have a huge can be hugely beneficial to that. So, for example, you have your endpoint detection system on a virtual machine. It's able to detect that there's some malware or reverse shell on your virtual machine. With a zero trust policy or a zero trust platform, it's able to talk to your federate system and say, hey, this machine is compromised. Do not allow it to authenticate to any of the resource it is. And it's able, and based on some of your automation you have, you can restrict it and completely block it off from the rest of your environment. So I do think there's a major benefit of that versus just using like passwords or service principals stored in the machine. So the identity can be tied to the lifetime of your resource. Everyone, thanks for watching this session of ThreatTraq. I hope this helps and you gain some knowledge out of it, and we'll see you next time.